Hello students, welcome back to my channel GBS Chem. In this module, let us discuss the states of matter, kinetic molecular theory. Please subscribe my channel, like, share and comment my video. We discussed about the various gas laws like Boyle's law, Charles' law, Gay-Lussac's law and Avogadro's law. In all these gas laws, we discussed the relation among the measurable properties like pressure, temperature, volume, number of moles, etc. And some questions may arise while discussing these gas laws, that is, why gases exert pressure? Why the volume of the gas is inversely proportional to the pressure? All these questions are answered by a theoretical explanation, that is kinetic molecular theory of gases or macroscopic model of gases. Therefore, the kinetic molecular theory of gases, the important postulates of kinetic molecular theory of gases. All gases are made up of tiny particles called molecules. In lower classes, we studied that matter is made of tiniest particles known as atoms or molecules. Atom is the smallest possible particle of the matter, whereas molecule is made of few atoms, maybe two or more. There are large spaces among the particles of the matter. So large spaces among the particles of gases. So the volume occupied by gas molecules, the exact volume occupied by gas molecules is largely less than volume occupied by gas. Volume occupied by gas. Molecules of the gases are not at rest. They are not in rest. Rest means without motion. Without motion. So the molecules of the gases, molecules are in rapid and random motion. Rapid and random motion. Random means no direction. Random motion means no direction. No particular direction. That means they have a zigzag motion. They move in the available direction and of course with high speeds. So since they have a rapid motion, see, these are the molecules. They collide with each other. And of course collide with the walls of the container. So during the rapid and random motion, molecules collide with one another, with each other or among themselves, and they collide the walls of the container also. Pressure of the gas. Just now we discussed that molecules collide with each other during their rapid random motion. During rapid random motion. So molecules move with high speed and without having any particular direction. They move here and there and they collide with each other and collide with the walls of the container. So here, this is the container of the gas and this is the molecule. It collides the walls of the container in different directions. During its zigzag motion. So during collision, against the walls of the container, some force is exerted against the walls of the container. Because of the collision, force exerts on the walls. So this is only one molecule, but as a large number of molecules exert force on the walls of the container, therefore large number of molecules exert force. So this force per unit area force per unit area, that is force by area equal to pressure. So since molecules collide, molecules bombard the walls of the container, force exerts, the force per unit area is called pressure of the gas. During the collisions, molecules do not gain energy, lose energy. So molecules do not lose or gain energy during collisions. So when they collide with each other, collide with the walls of the container, they do not lose the energy. Hence these collisions are called elastic collisions. Elastic collisions means during the collisions they neither lose nor gain energy. But only the thing is the energy may be redistributed. Redistributed means one molecule may lose energy, one molecule may gain energy. Redistributed. No attraction, no repulsion. During the collisions, no attractive force or repulsive force. No attractive force or repulsive force among the molecules. That is, molecules are independent to each other. Average kinetic energy of the gas. Different molecules have different energies, so it is not possible to measure the energy of each molecule. Therefore, the total energy exerted by the molecules is used to find the average kinetic energy of the molecules. Therefore, average kinetic energy of molecules or gas is directly proportional to the temperature of the gas. The average kinetic energy of the molecules is directly proportional to the temperature of the gas. Justification for the postulates of the kinetic theory of gases. How do we justify? How do we explain the different postulates? Postulate and justification. The first one is gases are made of tiny particles known as molecules. That is, matter made up of tiny particles known as atoms, molecules or particles. The first postulate is in accordance with the states of matter or nature of matter. Nature of matter means matter is made of tiny particles known as atoms, etc. The second one is molecules are separated from each other by large spaces so that the volume occupied by the molecules is negligible as compared to the total volume occupied by the gas. So here, this is the container of the gas and the molecules spread in this manner. Suppose if we are able to bring these molecules to close to each other, the exact volume occupied by the molecules only this part. So the exact volume occupied by the gas molecules is very less when compared to the volume occupied by the gas. Therefore, the space is largely empty, that is 99.19%, that is more than 99% of the gas has empty spaces among the molecules. Third point, molecules are not at rest but possess rapid motion and random motion. During their motion, they collide with one another and with the walls of the container. So here, this is the container. Molecules. So they collide with each other, collide with the walls of the container on different directions. So the explanation for this, if you observe smoke or dust, when vehicles pass on roads, lot of dust rises. This dust, the dust particles, they move in a random motion, zigzag motion. Zigzag motion. Dust particles, dust or smoke particles move at random. So this random motion is also referred as zigzag motion. This zigzag motion is known as Brownian movement. Brownian movement. The zigzag motion or random motion of particles in different directions is known as Brownian movement. The fourth point, the pressure of the gas is due to the bombardment of the gas molecules against the walls of the container. See here, this is the container. So these are the molecules. Molecules collide with each other and also bombard the walls of the container. When molecules bombard the walls of the container, some force is exerted. Some force is exerted on the walls of the container. Like this, many molecules exert force on the walls of the container. Therefore, the force per unit area on the walls of the container is known as pressure exerted by the gas, is called pressure exerted by gas. The collisions of the molecules with each other and with the walls of the container are perfectly elastic. That is, there is no loss or gain of energy. Energy may redistribute during the collisions. One molecule may lose energy to some extent, another molecule may gain energy which is equal extent. Therefore, ultimately, on the whole, there will be no loss or gain of energy during the collisions. Now, justification for this, if these collisions are elastic, if these collisions are non-elastic, there will be loss or gain of energy. Loss or gain of energy. That means as long as the gas is in the container, there will be no gain or loss of energy. Therefore, from this it is understood that the collisions are perfectly elastic, due to which there will be no gain or loss of energy. Not only that, when there is loss of energy, ultimately what happens after some time? Ultimately, molecules come to rest after some time. After some time they come to rest if there is a loss of energy. Now the sixth one, there are no attractive or repulsive forces between the molecules of the gas. They are completely independent to each other. We know that gases occupy the available space. So that is nothing but expansion. So indefinite expansion shows that the molecules do not have attractive forces. If attractive forces are there, then molecules attract each other and the expansion is restricted to some extent. Similarly, there is no repulsive forces. So this is the container which can be compressed. So this is the container with piston. So this is the gas. If the piston is pressed down, it comes down randomly. That is, the gas molecules are compressed. As gases are compressed, which indicates that there are no repulsive forces. Next point is, at any instance, different molecules possess different velocities and hence different energies. However, the average kinetic energy of the molecules is directly proportional to the absolute temperature of the gas. See, this is the container, different gas molecules are there. So this molecule has certain energy, say A units. This may have B units. Thus different molecules have different energies. It is difficult to find the energy of each and every molecule, but we can find the total energy of the gas present in the container, which we called as average kinetic energy. So this average kinetic energy is directly proportional to the absolute temperature of the gas. Now let us discuss about kinetic gas equation. Kinetic gas equation is PV equal to 1 by 3 mnc square. mnc square. So this is 1 by 3. Now what are these different letters? The different letters are P is the pressure of the gas, V is the volume of the container, in which it is kept, M is the mass of the molecule, of the gas, that is mass of each molecule. N is the number of molecules. C is the RMS velocity. RMS means root mean square velocity. C is the root mean square velocity. So this is the usual notation of all the letters present in it. So here number of molecules is represented by either small n or capital N. Any letter we can use. Therefore, thus PV equal to 1 by 3 m n c square, capital N. Now, average kinetic energy of the gas. Average kinetic energy of the gas can be calculated based on kinetic gas equation. Kinetic gas equation. What is kinetic gas equation? PV equal to 1 by 3 m n c square. Bring this V to this side. P equal to 1 by 3 m n by V into C square. For 1 mole of the gas, N equal to Na. So here in this PV equal to 1 by 3 m Na C square. Also, for 1 mole of gas, what is the ideal gas equation? PV equal to nRT. See here N is the number of moles. So N equal to 1. Therefore, PV equal to RT. But PV equal to 1 by 3 Na mc square. So this is number 1. This is number 2. So PV equal to 1 by 3 Na mc square. Equation number 1. PV equal to RT. Equation number 2. From 1 and 2, 1 by 3 Na mc square equal to RT. So here let us multiply with 2 and divide with 2. Therefore this is 1 by 2 into 2 by 3 Na mc square equal to RT. This is 1 by 2 mc square equal to, bring this 2 by 3 to this side, therefore this becomes 3 by 2 into R by Na into T. So 1 by 2 mc square is nothing but Ke. Ke is equal to 3 by 2. This is a K into T, where K is the K equal to R by Na. So this is a Boltzmann constant. So here this is finally Ke, kinetic energy of the molecule. Since K is a constant, we can say Ke is proportional to temperature, that is absolute temperature. Kinetic energy of the molecules is proportional to the absolute temperature. In the next module, let us discuss the Maxwell's distribution of speeds. Please subscribe my channel GVS Chem. Like, share and comment my videos. Thank you.